morning, Professor. Can you see me?
Good morning. Yeah.
Okay, so I'm doing number 39, and then number 39 asks a rectangular storage container with an open top is to hold 110 centimeter cube. The length of the base is 4 times the width. Material for the base costs $13 per centimeter square, and the sides cost $7 per centimeter square. It asks to find the cost of the material for the cheapest such container. So we put volumes equal to length times width times height, and since we know volume is 100 centimeter cube, I put it on an equation. And we can substitute the length as 4W since the length is 4 times the width. And then I will combine it and then have H equal to it, which will become 110 over 4W squared. Then we will find the cost of the base. And I put 13 because the material for the base costs 13 per centimeter squared. Then 13 times length times W, then I will get 52W squared. And the cost of the sides, to find the cost of the sides, it costs $7 per centimeter squared. So I will put 7 times 2 times length times height plus 2 times width times height. And then when I solved that, I got 1,925 over the width. Then to find the minimum cost, it's C prime of W equal to 0. Then when you differentiate, I put dc over dw times 52W squared plus 1925 over W is equal to 0. And when you differentiate and put W alone, you get the width is about 2.64. Then you substitute the width back into the equation to find the minimum cost. So C of W is equal to 52W squared plus 1,925 over W. And you will substitute W into the equation. Then you will get the minimum cost is about $1,091.06.
Okay. So maybe you want to write your C function here, right? Before you take derivatives. Your C function. Oh, you read here, right?
Yeah, C prime W equals 0.
Maybe you read here, right? Because I was getting confused. You were seeing to find, because we go from here, right? We go from here. Then you said to find the C prime of W. I said, where's the C prime of W? Where's the C of W? So then I see you have CW, C of W here, right?
Yes.
Yeah, okay. All right. Okay, pretty good. Anybody has any questions? Okay, so this question is typical, right? It's minimize the cost. Sometimes we want to maximize something, we want to minimize something. And here we want to minimize the cost. The cost is based on the square cubic meters of this material. So we want to form a cost function. As Victoria did here, he finds the cost of the base, cost of the sides, then she adds together, she gets a cost function. So this cost function is in terms of width, because the length is 4 times the width, so we can eliminate the variable length. So she formed a cost function, then find its minimum value. We just take, because this is a quadratic function, right? Quadratic function, W squared, the coefficient of W squared is 52 positive. So we have upward parabola. Upward parabola will have this minimum. The vertex is the minimum. So basically we want to find this point. So take a derivative, we set to 0 because the tangent line is horizontal. So it's a derivative at this point. It's 0. Then we just solve for variable W. Once we have W, because we want to find the minimum cost, Once we find the W, value of W, go back to the function, then we evaluate the cost. Great. Thank you, Victoria.
Thank you.
Okay, anybody else like to present? Or anybody has any questions? You know, on this review sheet, we still have some questions, right? Not being presented. So you may take this opportunity to present to get presentation credits. Okay, Angel wants to do 36. Let's see 36. Yeah, I don't think 36 has been presented. You can go. Let me make you presenter. Okay, go ahead. Oh, no, I made the wrong person. Angel. Okay, Angel, now you're a presenter. You can show your screen, share your screen with us.
Hello, Professor.
Yeah, you can go ahead.
Are you able to see my screen?
Yeah.
Okay. So for this question, let me find the direction. We are asked to find the area, the volume, and the volumes of the function when rotated across and about x and y axis. So on the left side, on the top left, I've found the area. The first thing I did is graphed it, as you can see, and then I found the points of intersection to find the lower limit and the upper limit. I found the lower limit and the upper limit by setting the two um, functions equal to each other, and then I found x equals 1 and then x equals -1. So that will be the lower limit and the upper limit. So the area of the function equals the integral of the upper function minus the lower function from -1 to 1. So it will be the integral of 1 minus x squared minus 0 from -1 to 1 dx And then after that, I found the antiderivative of 1 minus x squared using the power rule for integration, and then evaluated that from negative 1 to 1, and I found the area to be 4/3 units squared. And then, oh, do you want me to do the volumes too, or just the area?
Oh, of course, right? That's one question, right?
Yeah, and then under that, I solve for the volume and the function is rotated about the x-axis. There I graphed the function and the resulting solid when the function is rotated. Then same thing, I solved for the points of intersection and then found the area to be pi times outer radius squared minus inner radius squared. And then the volume would be that the integral of that area evaluated from is equal to the integral of the area from -1 to 1 dx. And then I just simplified 1 minus x squared and got 1 minus 2x squared plus x to the fourth. Then I found the antiderivative of that using the power rule for integration. And took out the pi since it's a constant. And then I evaluated that from -1 to 1 and found 16 pi over 15 units cubed. And then lastly, for the rotation about the y-axis, first I did was draw the solid, and then this time we're integrating horizontally about we're cutting across the y-axis. So I rewrite the function in terms of y and found x equals plus or minus -y plus 1. And then I solved for y by setting the two equations equal to each other to find the lower limit and the upper limit. But this time I just used positive square root of -y plus 1 and just multiply that by 2 since the graph is just reflected and it will be easier. So for the volume, so the area I found to be 2 pi times the outer radius squared minus inner radius squared. So that's 2 pi times -y plus 1. And then so for the volume, I did 2 pi times the integral of -y plus 1 dy from 0 to 1. Found the antiderivative of -y plus 1 using the power rule for integration, and that will be -y squared over 2 plus y, and evaluated that from 0 to 1 and simplified, and I got pi units cubed.
Okay. Great. First, I think the question I have a typo in it.
Yeah, because y equals 0 stay repeated.
Right. Probably this is supposed to be x equal to 0 to make better sense. But anyway, you follow the question. Sometimes in the question, if something does not make sense, we have to give a question mark, to try to make a comment, to go with common sense. So basically the question is y equals 0, x equals 0. So basically we see this part, right? But anyway, let's go with your solution. Okay, so you have x equals to 1 and -1. Can you mark those values in your graph? Because once we have a graph, it's very important to give some important values.
Mm-hmm. Let me try to write it there. Oh. I really can't try to make it close to the, because I'm using my phone right now, my laptop's lagging.
It's okay, I'll write for you. So basically this one, oops. Basically this here on the left hand side, this is -1 and this is a 1.
Mm-hmm.
Right. Okay. So your area is this. Now we revolve with x-axis. Right. We revolve with x-axis. This is x-axis, right? X-axis goes this way, right? Okay, so we use the formula pi r squared. Can you tell us why r is 1 minus x squared?
Mm-hmm. Because the radius should be from y equals 0 to the most upper function.
Well, can you draw the radius?
Yeah, I just drew it. I just drew it on. Are
Oh,
you able to see it? I just drew it and then erased it. I draw it again. Hello?
somehow I don't see it.
Oh, you don't see it? It's on the first graph on top.
Oh, on the first graph. Oh, you draw the first graph.
Yeah, because it's
Because we were talking about this, right? So if you draw on the first graph, it doesn't make sense. The first graph has no radius. The first graph is a 2-dimension.
Oh, because I really can't draw it because it's too small. Yeah.
Let me do for you.
Yeah.
Okay, so the radius is this. Let's just pick one point. Right? At this point, we see this. The radius is just this. So it's the top function, which is 1 minus x squared, minus the bottom function, which is y equals 0. Okay, let's see this one. So now we'll go around y-axis. So can you show us the radius here? Also, we use pi r squared.
It's from x equals 0 to. Can you see what I draw?
Yeah, from x equals 0 up to
here.
To here.
Yeah.
What is it? Right, to this graph, right, to this part. To this part.
Yeah,
so how do you find this part?
Which one?
I marked it with black color.
Yeah, that's positive negative y plus 1. Positive x equals negative y plus 1.
Oh, okay. So basically you are seeing, so this graph is y equals to 1 minus x squared, but we need to find x value because r here, right, the radius here is the x value, but the x value is changing. X value is changing in terms of a y value, so we need to solve for y, solve for x. So we use the equation, we solve for x, then we get x equals to plus minus square root of 1 minus y. Okay, great. So let's see, that's your R. And because we're on top, we're on the, so you see right now, we have to, you see here, X has 2 values, right? Has negative, has positive. So then how would you use this X equals to negative and positive 2 values?
Since the graph is just reflected and it's symmetric, so I just use the positive value.
Right. So now from here, actually, you can go back. You know this 2. You know this one, right? You want to make x equal to 0 to make a better sense of the question, right? But anyway, All right, great. Great. Okay, good job, Andrew.
Thank
Thank
you.
you. Anybody has any questions? This should be x to make sense. X equals 0, which means y equals 0, x equals 0. That means we want to bound the graph in the first quadrant. Okay, not all of you get presentation credits, right? Full presentation credits. So you can take this chance to present. Okay, Stanley wants to try 27. Sure, go ahead. Stanley already made your presenter. Yeah, we can hear you now.
So this question asks us to evaluate the integral of sine to the third power of x to cosine x. So I did use SOAP for this for u equals sine x. And what I did here was figure out du over dx equals cosine x, and then I multiply dx on both sides to get cosine of x dx equals du. And then when I subbed in sine x to sine to third power x, I got u to the third power, and then I put du since du equals cosine of x times dx. And then I used the power rule to evaluate the integral, and I got u to the fourth power divided by 4, and then I sub back u, which is sine x, so then I have sine x to the fourth power divided by 4, or 1/4 sine to the fourth power times x, and my answer is 1/4 sine to the fourth power of x plus c.
Yeah, that's it, right? What kind of integral we call this?
Indefinite.
Indefinite integral, right? We won't be able to get a value of it, but we get a family of functions. Okay, anybody has any questions? Anyone has any questions? Okay, great. Thank you, Stanley. Anybody else like to show, present? Or anybody has any questions? Uh, if not, I guess we're ready for the final exam. So I guess all of us are ready for the final exam and be done with this semester, right? Angel, what do you mean you want to try again? You mean you want to try another question? Sure, of course. Which one you want to try? Which one? You have to try the ones not being presented yet. Oh, 45. Go ahead.
Professor,
Yeah.
are you able to see it?
Yes.
Oh, because it's still loading for me.
All right.
I just use
It's okay.
my
We're not
social
in a hurry at all today. Let's take time.
Oh, there, just loaded.
Okay.
So for this question, we are asked to find the derivative of the function kx equals I'm sorry, to find the derivative of the integral of sine 5t cosine 5t squared dt from 2x to 3x. So I used u substitution for this one. Oh, the first thing I did was split the integral into two parts, from 2x to a, then from a to 3x, and assuming that a is between 2x and 3x. Then for u substitution, I set u equals to 3x and u equals to 2x, then find du over dx of 3x equals to 3, and then the d over dx of 2x equals to 2, and then which are the derivatives of the two functions, 3x and 2x, and then I did d over du times the integral times d over dx, which is the same as d over dx. Then I used, from the second line to the third line, I used the first part of the fundamental theory of calculus, which states that the derivative of the antiderivative would be the original function. So we get the sine 5t cosine 5t squared as the result. But this time we use the use of substitution and substitute u for t. So we get, oh, and also there's a negative sign introduced in the second line since we changed the lower limit and the upper limit. We switched them so that there will be a negative sign there. And then we substitute also 3 and 2 for du over dx for both sides. And then we simplified and get negative 2 cosine squared 10x times sine 10x plus 3 cosine squared of 15x and times sine of 15x.
Okay. So yeah, as you said, we because this kind of question, we want to use the first part of the fundamental theorem of calculus. The first part of fundamental theorem of calculus, we have this kind of, let me mark this. We have this kind of form. So if we want to find, so K is defined this way. So let's say if here it was A, so K prime of X would be just a substitute the dummy variable T into the upper limit, then multiply by the derivative of the upper limit. So that's first part of fundamental theorem of calculus. So that's why Angel split this integral into two parts. She's saying, okay, my lower limit is 2x with variable. My upper limit is 3x. My upper limit looks good, but my lower limit is not a constant. It's not a number. So what do? We just choose a number A. You know, A can be any number. You know, maybe if x is not 0, this is in between of those two values, 2x or 3x. Then split this integral into two parts. So writing from 2x to 3x to be 2x to a and a to 3x. Why we can do this? Because we know the integral of the lower, when the lower limit and the upper limit equal to each other, the integration is 0. So at a, from a to a, the integration is 0. That's why we can split into two parts. Split into 2x to a, then a to 3x. Then we want to put it in a form to apply fundamental theorem of calculus. So we need the lower limit to be a constant, upper limit with a variable is a function. So we switch the lower limit to x to a as from a to 2x. When we switch the lower limit and upper limit, then introduce a negative sign. Then Andrew is saying, okay, now let's use U substitution. So how do we do U substitution? When we deal with trig functions, we're looking for the trig function with exponent because cosine has exponent 2. So what do we do? So this square, either we write as this, parenthesis square, or we write this square here. All right. Otherwise, this seems like a 5t squared. It only square this part. So if we want to write that way, we put a parenthesis around. Oh, I see. Right. The question should have a typo in the question. So we choose the trig function with exponent to be u. Then the one, like here in this case, the trig function sine has no exponent. So that would become du part of du. So apply both with u substitution, we integrate the integrand, then we substitute back u term, then right when we substitute with the upper limit, we have to remember to multiply by the derivative of the upper limit. Then we simplify. Okay, great. Anybody has any questions? Anyone has any questions? Good job, Angel.
Thank you.
You're welcome. Okay, next. Anybody else like to present? Anyone has any questions? Okay, if you don't have questions, let me ask you maybe 2 questions. So the first question is, do you receive a final exam date yet from CUNY or from anywhere else? Okay, right. I haven't either. I have not either. So that means, because we finish early, that means maybe we can schedule our own final exam date. So I have 2 options, 7th or 14th, 2 Mondays. Because maybe some people need more time to catch up with homework or presentation. In that case, we can do on 14th. So you still have 2 weeks to catch up, to study. Or if most of us feel comfortable, we don't want to waste any time, we just want to finish, we could have final on 7th, which is next Monday. So by choosing 7, you type in the chat. So that means you prefer to have on 7. By type 14, that means you prefer on 14. Okay. Julie is asking, will it be on Lumen? No, it'll be just like this, face to face. So you show me your face. I show you, I'm going to practice the exam, except that some students have special situation. You need to contact test accessing center, I think. They will practice you, and they will give you, more time to do the final. They will ask me to send to them the final exam, which I will do, and they will protect you. And for the most of us, will meet here that day. All right, you need to have your camera on. Basically, it's an open book. You have your student ID with you. Basically, it's an open book exam, right? And very similar to your review sheet, but with different numbers. Yeah, I'm not going to restrict you to not look at your look at your books or notes. Okay, so I think most people like to do on 14th. All right, so let's agree on 14th then. So I'm going to put on the announcement. So we're going to have final on 14th. Is 7:10 okay for you? The same time? If it's not okay for you, let me know. So if you, right, I assume we're getting used to this time schedule. Oh, let's see the question. Oh, if you do not have your student ID, use any of your picture ID, maybe lessons. All right, so basically to confirm that is you, that is a student. You are the student who's taking the final exam. That is the purpose of it. It's like a tradition of a Hunter test. Is that okay with everybody? If you do not have student ID, have a picture ID with your name on it, with your picture, with your name on it, all right? How will it be done when many students are here at the same time? What do you mean? Okay, once you finish, right? Once you finish the exam, submit through CUNY Blackboard. Not sent to my email. I will have details on the announcement, so you know exactly what to do on the final date. Andrew is asking, so there's still two parts of the final? Two parts of the final? Oh, you mean presentation? For some of you, for some of students want to get better grades. Yeah, but if you, we'll see. The presentation for final is optional. All right, it's optional. Let's see what else. Oh, the final is the same time. It's 2 hours. It's 2 hours exam. Does high school ID work? Yeah, if the picture looks like you. All right. If the picture still presents you and with your name on it, it's okay. How many questions? Yeah, I said from 15 to 20 questions, right? Very similar to the review sheet. Can we take a bit later if possible? If no one else wants to switch the time, then 7:10 is fine. I see. Will the question we present be given to us at the time and date, or will we be given those questions a bit beforehand? For the final presentation, no. For the presentation, I will choose, right? Let's see. If in a situation, I was thinking the student could get a better grade, right? I would probably send him or her an email to ask, I'll ask this person some questions. If he's able or she's able to answer my questions, she understands. I feel she or he understands. The material, and he or she may deserve a better grade. All right. Let's see. So I'm not going to give a beforehand. It's not like homework. Homework, you can choose what to present. You can prepare. For the final, no, you don't have a chance to prepare anymore. And I will ask you to explain something to me. All right, let's see, anything else? So Andrew is asking, so we need to take a picture of our work and upload on Blackboard. Yes. So I'm going to open a session called a final exam submission. So you submit through that. I just learned this trick. I didn't know this before. I just learned. So when you submit your final exam, you need to take your photo, your picture ID. You need to put your picture ID on top of your work. All right, on top of your work. Then to take pictures, send to me. All right, and let's see. Any other questions? Sometimes people run into like a problem submitting. Can we email it to you? You mean through Blackboard? Yeah, if through Blackboard you have some difficulties, yeah, you can email it to me. Yeah, those days we always need plan B or plan C. All right, any other questions? So basically, yeah, I think most of us have done very well. So, keep studying, be comfortable, practice always makes better. So, we still have 2 weeks to practice. And so I'm going to add one more question. So we still have Thursday, which is 3, Monday, 7th, and the 10th. So before our final exam, we still have 3 more classes. So what do you think we should do for these 3 classes? Anybody has any suggestions? Maybe go over review questions that students are having trouble with. Well, that would be ideal, right? That would be ideal. That's why I keep asking if we have any questions. Victoria, I would like to present more questions. Okay, great. Noella, more practice questions and have the structure similar to the final. Noella, that one you can do yourself. Just change some numbers, change some format, right? Let's give some examples. Let's see for the integration, right? You could change it, let's see the 42. You could change, this integrand to be something else, right? Something, similar to it. You can change the numbers and variables around. Same thing, right? You can change, if the sine, maybe you can change to cosine, right? Or secant, cosecant, tangent. Here, 45, maybe you want to switch sine and cosine, right? Maybe you want to raise the power. Maybe you want to give both powers, right? Or go to the exercise, right? After the homework, each section has a homework. Go to the homework set. Yeah, it's 41. You can change the numbers around, right? For graphing, same thing, right? For graphing. Remember the graphing, right? Remember this graphing. This graphing, you're not supposed to graph on your calculator. You may finish the 7 steps, then use your calculator to conform your graph. But before you go through these 7 steps, try not to use the calculator. Try to follow the steps. Right? Then once you finish, you conform with your calculator. If you get the same graph as the calculator does, you are doing right. If you have different graphs, you may think, okay, what's going on? What did I do wrong? This is the process of learning. And also for those functions, right, you can change things around, right? Similarly for here, right, you can change this integrand. Absolute function, we have a special skills to deal with absolute function as an integrand. Change numbers around, change the variables around, change the lower limit and the upper limit around to see what you get. Sine, right? You may want to switch the cosine. You may want to switch, let's see, this angle. Maybe you want to switch this angle, change this angle to be some other expressions. For this lower limit, when the lower limit and the upper limit are the same but opposite, we have another strategy to use, right? We want to figure out if the integrand is an even function or odd function. Right? If it's an even function, we get one solution. If it's an odd function, we get another solution. Right, for 17 also, right, find the difference quotient. This basically is algebra, right? Not even calculus. But we know in calculus definition, in the definition of derivative, we use this differential quotient. So this is basically the algebra. You can change the function to be another function, then go through this difference quotient to practice. For implicit differentiation, change the expression, right? Change around to see what's going to happen. What kind of, right? Change the questions around yourself. Okay, let's see other questions. Yeah, ask the questions, Rudy. Everybody be brave. If you have any questions, maybe from homework, maybe from the presentation sets, right? Remember, after each section, I choose a couple questions for you to present next class, or from this review sheet, or make up your own question, right? To try, to go through the trial and error steps. If you have questions, ask. Okay, so let's do this. So we're going to meet before the final, we're still going to meet the same time. And each time you can ask questions. You can present. You still can present to earn your presentation credits. And right, if you have questions, I encourage you to try. If you make errors here and there in your presentation, I'll try to be helpful. I'll try to help you to gain the presentation grades, all right? But if you have no idea how to solve the question, but somebody else helped you, to solve the problem, but if you don't understand it, you probably won't earn any credits for that. It's great to have someone help us to solve the problems, right? But the more important thing is we need to understand. We need to understand ourselves how to solve the problem. Okay, Jason wants to try 38. Let me make a presenter. So 38, okay, 38 is a word problem. Yeah, remind us the question first, Jason.
Hello.
Yeah.
So we're trying to find the cheapest cost for an open box when it costs $15 per centimeter square for the base and $8 per centimeter square for the sides. So the volume of the box is 10 centimeters cubed. So we know that the volume is 10 centimeters cubed, and since so I set the width to x and y to the length and z to the height. So we know that the length is 2 width, so I set y equals 2x, and then z we find z by using the volume. V equals xyz. So I plugged in y, which is 2x, and then to solve for z, I divide volume by 2x cubed, squared. So z is 5 over x squared. So we found xyz, and then to find the cost, there's two of each side panels for the container. So first, it's side right 8 parentheses the area of one of the sides, which is these two sides, 2xy, xz, and then plus 2 yz, these two, and then we add the cost of the base, which is the area of the x and y. And then I simplify that by factoring out 2z, which you get 16z over here, plus parentheses x plus y, plus 15xy. And then I plugged in z and y down here. Plugged in 5 over x cubed, squared for z, and 2x for y. And then finally, after that, you get this expression. And then to find the cheapest cost, I set c prime to 0. So to find x when c prime is 0, I set 60x equals to 270 over x squared. And then I solve for that by multiplying x cubed to the other side. I get 60x cubed, x squared to the other side. I get 60x cubed equals 270. I divide 270 by 60, and then I cube root it. And then I simplify. So x equals cube root of 9 over 2. and then I plugged it into the equation we got here to find the cost, the cheapest cost. And then when I plugged in, I got $87.50.
Great.
That's it.
Great.
Th-
To
Thank
make it more precise, right here. Oh, I cannot write. C prime. You said it, but you didn't write on it. C prime of x equals 6x minus 270 divided by x squared equals to 0, right?
Yes.
Right. Then you know the following steps will make sense. Great. So I get, excuse me. I'm hoping, excuse me. I'm hoping all of us see the steps, right? Victoria showed one, is Victoria or Angel? Showed one of these kind of questions, right? This is a typical calculus, a strategy using in life. We always want to minimize cost for business, for running business. So this is a minimize cost. So we need to form a cost function. So which Jason did here, right? So he formed a cost function. What is this function? We see this function is very well known, quadratic function, right? And the 30 is a positive number. So again, we get a upward parabola. So we're trying to find the minimum point. Okay, anybody has any question? Okay, great, Jason, thank you. Okay, anyone has any question or like to present something? If no one has question, when no one is ready to present this time, I guess I'll see you on Thursday. If some of you want to speak to me individually, you can let me know, right? Okay, I see you on Thursday then, all right? Thank you, guys. Go ahead and really ask.
So I finished chapter 2 quiz, but for some reason it's not showing up under the.
You're not
the
alone. Many people have the same question. Don't worry about it. If you finish, somehow it showed on my side. Let me
Okay,
check for
okay.
you. Hold on 1 second. Yeah, many students already have this problem. Did not show on your side, but they showed on my side.
Okay.
Let me just make sure. So second exam, right? Second
Yes.
quiz.
Yes.
The platform has some bugs. Yeah, I have everything.
All right, thank you so
We're
much.
done. Yeah. Okay. Good job.
Thank you. Thank you. Have a great day.
You too.